ladies and gentlemen, how are you doing? I hope you're doing very well. Hope you're feeling well. And today we have another fun-filled lesson that we're going to teach today. Today we're looking at section 8.1, which is the algebra of functions. So we're going to be taking polynomial functions and we're going to be adding them, subtracting them, multiplying them, dividing them, and seeing what new function we can produce from these operations. So, with that being said, take a moment, copy down the notes, and we shall come right back to you. Alright? Copy them down. Okay, welcome back. Let's get started. 8.1. So, when we talk about the algebra of functions, we're taking polynomials, right? And we're just doing these various operations on them. We are adding them, subtracting them, multiplying them, dividing them. So, this reads the f plus g, this sum of x. It can also be written as f of x plus g of x. Okay? Here we have the quantity f minus g of x, which is the same as f of x minus g of x. Here we have f times g of x, meaning that I want this product evaluated at whatever x is. That's the same as f of x, f evaluated at x, times g evaluated at x. Okay? Here we have the quotient of f divided by g of x, which is f of x divided by g of x. So the point is, you can write these things different ways, right? You can express it like this or like that. Same thing, like this or that. One or the other. It's okay. Alright? So let's do an example here. Alright, so here we have f of x, which is x squared plus 5, and g of x, which equals negative x plus 9. Alright? Let's find f plus g of negative 7. Let's find it. Here we go. Now, it can be rewritten. Watch this. Here we go. F plus g of negative 7. This is the same thing as, right here, I can write f of negative 7 plus g of negative 7. Alright? So what this means is you can go ahead and put negative 7 inside of the function f. And let's see what we get. Negative 7 inside of f. Well, what is f? F is right here. So that's going to be f of negative 7 is going to equal negative 7 squared plus 5. That's f of negative 7. And I want to add that to a plus sign, if you will. Okay, now let's find g of negative 7. Alright, well, g of negative 7 is going to equal, where's g? G is right here. That's going to equal negative of negative 7 plus 9. See this negative here? It just comes straight down. And x itself is negative 7. It's like you can put parentheses around this if you want, like that. See that? Alright. And so what are we going to get right here? What is this going to give us? Well, negative 7 squared is 49 plus 5. And 49 plus 5, this right here is going to give us 54. Got it. Bring down the green plus sign. Plus. Let's see what's over here. Alright, so what does this give? Well, the negative of negative 7 is just 7. Plus 9. And 7 plus 9 is going to give us 16. So we have 54 plus 16. All right, well, we know what that is. 54 plus 16, that's going to equal 70. And that's it. There's the answer, 70. I took f of 7, got 50, f of negative 7, 54. G of negative 7 is 16. And 54 plus 16, 54 plus 16 is 70. So therefore, I can go back here where it says find f plus g of negative 7. That just simply equals 70. And we're done. That's it. Here's our answer. That's how you do it. Example 2. Find four-ordered pair for f of x. So if we want to find four-ordered pair, right, we need an x-coordinate, y-coordinate. That's one ordered pair. Another x-coordinate, y-coordinate. That's the second ordered pair. Another x-coordinate, y-coordinate. That's the third ordered pair, right? So we need x and y coordinates. Those are ordered pairs. All right, so to do that, we have to find out what we want to let x equal. All right, so starting off, I'm going to let x equal 4. I'm going to start with 4. So if I let x equal 4, I'm going to have f of 4, which equals the square root of 4 minus 4. And so f of 4 equals the square root of 0, which is 0. All right? So what does this mean? This means that when x is 4, this means that x is 4. That's where we started. When x is 4, this is the y value. Then y is 0. So my first coordinate point is 4, 0. See, you determine what you want to let x equal. So I'm going to let x equals 4. Because 4 minus 4 is 0, and the square root of 0 is an easy root. So you determine x based upon what you're given. So you want x, once you do the operation, you want to have like a perfect square, because they're easy to find the roots of. So choose a number x that will give you a perfect square for the argument. You want the argument to be a perfect square. That's how you determine what x to choose. For example, so this is the first ordered pair. For my next ordered pair, watch this. I'm going to let x equal 5. Because if I let x equal 5, I'm going to have another perfect square. Or perfect square to choose from. Watch this. F of 5 equals the square root of 5 minus 4. So f of 5 equals the square root of 1. See that? And we know the square root of 1. Why do I have a 1 right here? Because of the 5 I chose. 5 minus 4 is 1. And you choose x. You choose the x value. Alright? And so f of 5 equals 1. Please remember that this is the x value and this is your y value. So the next coordinate pair, the next ordered pair is going to be 5, 1. So I have 5, 1. Now what are you going to let x equal? After 5. Alright, I'm going to let x equal 8. So then f of 8 equals the square root of 8 minus 4. And so f of 8 equals the square root of, well, what's 8 minus 4? 4. You see that? And that's good because I can find the square root of 4. Right? And so f of 8 equals 2. So my next ordered pair is going to be 8, comma 2. All right, I have one more ordered pair to find. Here we go. Now I'm going to let x equal, what do you think? What should we let x equal now? Okay. I don't suggest this. Let's take a look at it. Watch this. I don't suggest you do this, but I'm going to show you. Someone's going to say, well, let x equal 9. All right. Well, look. Let x equal 9. Then f of 9 equals the square root of 9 minus 4. So f of 9 equals the square root of 5. Really? Can you break down the square root of 5? What can we do with that, square root of 5? Nothing. So let's not use that one, because you can't, it's not a perfect square. So don't let x equal 9. That's not a good choice. That's not a good choice. 9 is not a good choice, because 9 is going to give me a 5, and 5 is not a perfect square, so I'm not going to use x equals 9. Boo. No. What do you think we should use? What'd you say? 13? Okay, let's try 13. Okay, let's see what we get. So f of 13 equals the square root of 13 minus 4. F of 13 equals the square root of 9. Oh, wow. Now that's a little bit better, because now we can find the square root of 9, right? And what is the square root of 9? The square root of 9 is 3. So when x is 13, y is 3. And that's my last coordinate point. It's going to be comma 13, comma 3. And so, ladies and gentlemen, here are my 4 ordered pairs. All right, there's my answer. Check, check. Those are my 4 ordered pairs. But remember, you choose the x. You choose the x. All right. Example number 3. Now I want f minus g of x. Okay. So let me rewrite it. So f minus g of x is the same as f of x minus g of x. And notice this time the x is just x. There's no value right here. It's not like we did over here. That was -7. This is just x. Leave x. No, do not evaluate at any value. Okay? Just leave it x as x. All right. Well, first off, let me write first, what is f of x? F of x is x squared minus 16. So write that down. X squared minus 16. Okay? And so is this whole thing x squared minus 16, and then it's minus. See the minus sign? See that minus sign? So write the minus right here. Minus. Okay, very good. Now what is g of x? G of x is 2x squared minus 5x plus 1. Okay. 2x squared minus 5x plus 1. There you go. Now we're back at lesson, oh gosh, I can't remember what it was, 4.1 or 4.2. We did this here when we were, learning about polynomials and, how to subtract and add them. So here we go again, right? Here we go again. So what we do in this case, the first polynomial, this one, just rewrite it without parentheses. So that's going to be x squared minus 16, no parentheses. And then what I recommend you do right here is, get a piece of paper. You see this minus sign? Well, that's a minus. That minus sign has to be distributed in this next polynomial here. So what I suggest that you do, get a piece of paper, cover up everything up to the parenthesis, and everything inside the parenthesis make it opposite. So a positive 2x squared becomes negative, a negative 5x becomes positive, and a positive 1 becomes a negative 1. So there's the minus sign. That has to go inside of the polynomial here, inside of the parenthesis. So if I cover it up, whatever you see right there, just change the sign. So what's positive becomes negative, what's negative becomes positive. So that positive 2x squared now becomes a negative 2x squared. And that negative 5x becomes a positive 5x. And that plus 1 now becomes a minus 1. That's the same as taking this negative and distributing it. It seems that, over the years, the more we say take the negative and distribute, students still can't seem to put a grasp on it, or put their hands on it. They still kind of get it wrong. So I just always suggest, when you have a negative in front of parentheses or in front of a polynomial, yes, you multiply by negative 1, or just simply take the paper, cover up all the way, cover everything up to the negative, and take what's in the parentheses right here and just make it opposite. Positive 2x, make it negative 2x. Minus 5x, make it positive 5x. Plus 1, make it minus 1. Make it all opposite. And then combine like terms. Alright. So, if we combine our like terms, let's do that. We have a minus x squared and a positive x squared and a minus 2x squared. That's going to give us a negative x squared. And we have a positive 5x. That's it, all by itself. Plus 5x. And lastly, we have a minus 16 and a minus 1. What's a minus 16 and a minus 1? Minus 16 and minus 1 gives us a minus 17. And we're done. There's our answer. Check. That takes care of that. Okay? So a lot of these techniques, ladies and gentlemen, you've seen before. It's nothing new. It's nothing new. Just don't panic. Breathe easy. Right? We've seen it before. Alright. And then we have example 4. We have f of x, which is x squared minus 4x plus 4. And g of x, which is x plus 2. And we want to find f divided by g of x. Alright, well this is the same thing as, here we go. This is the same thing as f of x divided by g of x. Which equals, okay, what is f? F is x squared minus 4x plus 4 divided by g of x, which is x plus 2. Pretty much it. You might want to state the restriction on here. X cannot equal negative 2. Because if x is negative 2, it causes our denominator to be 0. We don't want that. But that's a wrap. Just that simple. Check, check, check. And that's it for that. Alright. Okay. So So what have we done? We've added, we have found ordered pair, we subtracted, we divided, and now we have a very unique situation happening over here. Alright? So basically we have a coordinate plane, and on the coordinate plane we have two graphs. One of the graphs purple, one of the graphs blue. We have a decreasing graph that's purple, increasing graph that's blue. Alright? And you're going to be asked to do some things like what? Find f plus g of negative 3, f minus g of negative 3, f times g of negative 3, and f divided by g of negative 3. Okay? And so to do this, we give you the process. Here's the process. 1. Identify the x value. Very important. 2. Find the corresponding oh, oops, this is not spelled correctly. That's too many O's. There we go. 2 R's, not 2 O's. Find the corresponding y value on both graphs, f and g. So find the x, then find the corresponding y value on both graphs, f and g, and perform the operation. Either add, subtract, multiply, divide with the y value. Do those 3 steps, and you should be good. Let's take a look at those 3 steps. Here we go. Alright. Pretty easy. Stay with me. So, this right here equals. Here's the first one. Alright. You have to realize that this f of negative 3, that is the x value. So, for this one, and for all of them, x equals negative 3. Identify the x value. That is the x value right there. Mr. Wright, how do I know it's the x value? Look where it is. Check it out. It's right here. Negative 3. Okay? Come back over here for a second. See this? X. 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 You see that? X. Therefore, since this is x, 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 then this must be the x value. X is negative 3. So we got that established. Our x value is negative 3. Find the y value, the corresponding y value. Well, let's go and find the y value. Alright? And so if we do that, let's do the purple first. The purple y value, the purple line is g. So g of negative 3, what's my y value? Y value goes there. And then I want, what is f of negative 3? Y value goes here. Let's do purple first. Alright, well if x is negative 3, please find negative 3 on the x-axis. This is the x-axis. See that? X. Here is 1, 2, 3, 4 on the x-axis. Where is negative 3 on the x-axis? Can you find negative 3 on the x-axis? You can. Let's see. 0, negative 1, negative 2, negative, congratulations. We have found negative 3 on the x-axis. Good job. Let me write negative 3 right here. Negative 3. Good. This negative 3 is that number right here. It's that number and that number and that number. That one, that one, that one. We found negative 3. What you have to do is find the corresponding y value. They give you the x. Find the y. Here's how you do it. Find the y. Alright. So draw a picture of you on -3. Here you are, and you are standing on -3. Yay! All right, from -3, you have to go up to the purple graph. Now the purple is G, so I'm going to do this one right now. Go up to the purple. From where you're standing, just jump straight up. Look, see that? Jump straight up to the purple graph. Jump. All right? So you jump. Bing! See that? You jump straight up. You hit the purple graph. What's the Y value right there? Let's see. Oh, the Y value is 2. See? 2. You jump. Boom. And you're on 2. So a 2 goes right here. Good. Now, you did purple. Now do blue. Don't jump up. Now you got to fall down. Just got to fall down. See that? Go straight down and touch the blue graph now. Let's go straight down. All right, we touch blue and go over. What's the Y value? The Y value is -3. Congratulations. Yay! You found your Y values. Here they are right here. You got both of them. Now all you have to do now is perform these operations on the Y values. You see the Y values are circled in green, which means now you got to add those Y values, subtract those Y values, multiply the Y values, divide the Y values. That's all you have to do, and this is done. I think you can do this. All right, so let's go after this one first. Here we go. If I add the Y values, it's F plus G. This one's F. -3 is F. So it's -3 plus 2, which is -1. So that's the answer. So F of G plus 3, F plus G of -3 equals -1. All right, equal. Now subtract. Now with subtraction, the order matters. You got to put F first. F minus G. Because F minus G is not the same as G minus F. Order does matter with subtraction. So put the Fy value first. Where's F? Right here again, -3. So it's going to be -3 minus 2. What is -3 minus 2? It's -5. So F minus G of -3 equals -5. All right, what does this equal? Well, let's multiply now. Let's multiply. So you want to multiply F times G. Doesn't matter. -3 times 2. -3 times 2 is -6, and there you go. So F of G of -3 is 6. And then we want to divide. F on top. That's going to be -3 divided by 2. Congratulations, we're done. That's it. That's it. Okay? All right. Let's do another example of this one. Let's find another one. Let's do one more like this. Let's erase this. Let's erase this. All right. Let me see. Let's find F plus g of negative 1, g minus f of negative 1, f g of negative 1, and yeah, let's go with that. Okay, so first identify the x value. It's given. X equals what? Negative 1. Good. X equals negative 1. Got it. Step 2. Find the y values, ladies and gentlemen. That's the key. So let's go with f. F of negative 1. What's my y value? And g of negative 1. What's my y value? Give me those y values. Alright. Well, looky. And that, oh, looky here. When x is negative 1, what is the y value right here? For both of them. That's no fun. Because when x is negative 1, y is just 0. Oh, and by the way, let me get rid of these lines. I don't need them no more. We've done negative 3 already. Get rid of you, get rid of that, get rid of this. Alright. When x is negative 1, the y value is 0 for both graphs. So it's going to be 0, 0. Oh, we can't do that one. That's no fun. Boo. Why? Because this is just going to be 0 plus 0, which is 0. 0 minus 0, which is 0. 0 times 0, which is 0. And division by 0 is undefined, which is beyond the scope of the class. That's why I didn't put division right here. That was no fun. Okay? How about we look at, let's see. Let's look at f of 2. Let's change this now, because that one wasn't too good. That was no fun. There was nothing to do. Let's look at f of 2. 2, 2, 2. Now the x value is 2. All right. I'm going to change this. So now my x value is 2. 2, 2. Okay. Let's find f of 2. Alright, so I know my x value is 2. Where is the number 2 on the x-axis? I think we can find that. Let me see. 0, 1. Here it is. There's 2. I found my x value. It's 2. It's 2. X is 2. X is 2. So x is 2 right here. Draw a picture of yourself. Draw a picture of you on 2. Okay. There you are. Once you find the x value and it's given to us, I need the y's. Find the y value. So where you're standing on top of 2 right here, why don't you just jump up and let your head touch the blue graph. Touch the blue graph. Jump straight up. Jump, 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 jump. Jump straight up. Okay. Well, this is off a little bit. Let me recalibrate it. I don't want it to be off too much. That's good enough. Alright, so I'm going to jump up, hit the blue graph, make your way on over. Look at that. What's the y value? 3. So the blue graph, f of 2 is 3. That's a 3. F of 2 is 3. We got it. So now don't jump up, just fall down. Let's go to the purple. All right, f of 2. F of 2. Come on over. There we go. And so what is f of 2? Negative 1, negative 2, negative 3, negative 4. And these would be friendly numbers. There won't be nothing in between. If it were, it's okay. But it's not in this case. So g of 2 is negative 4. All right, there you go. There are your y values. The purple and the blue. Do everything with these two numbers. So f plus g of 2 equals, well, it's the f value, which is 3, plus negative 4, which is negative 1. So f plus g of 2 equals negative 1. How about g minus f? Notice this time it's g minus f, not f minus g. G comes first. The y value for g is negative 4. So it's going to be negative 4 minus 3, which is negative 7. All right. And how about, oh, let me write here, f of g of 2. All right, and how about f times g of 2? So now take these two numbers and multiply them. So it's going to be 3 times negative 4, which is negative 12. Got that. And then let's go f of g of 2, which is going to be f, which is 3, divided by negative 4 is negative 3/4. That's it. Any questions about it? Any questions here? Any questions? Okay, the last thing I want to take a look at. The last thing I want to take a look at before we end this lesson . The last thing I want to take a look at. Let's do example number. Let's do our last example here. Let's see here. All right. Getting back over here, I think we had maybe, what, 4 examples over here? 1, 2, 3, 4. And this right here was example 5. Then example 6. Maybe we're like on example 7 now. Okay. F of x equals negative square root of 3 minus x. And g of x equals 4 minus x. Okay? 1. Let's find g minus f of x, and 2. Okay? Let's state the domain in interval notation. State the domain. Let's state the domain of f of x. State the domain, add it right here, of f of x. State the domain of f of x in interval notation. State the domain of f of x. in interval notation. So the first thing we need to do is find g minus f of x. All right, so here we go. So g minus f of x is the same thing as g of x minus f of x. That's first. All right, so write g of x first. Here we go. G of x is 4 minus x. That's g of x. 4 minus x. Bring down the minus sign. Right there. Now write f of x. F of x is negative the square root of 3 minus x. Okay, we've done it. This is g of x minus f of x. Okay? Now all you have to do now is understand, recognize, realize, what is this going to give me when you have two negatives like that? Anyone know what a negative times a negative is? If you say positive, you are correct, because a negative times a negative is positive. So I'm going to have 4 minus x plus the square root of 3 minus x, and you're all done. That's it. That's the answer. Check, check. That's the answer for number 1. Number 1 is answered. Okay? Number 2. Now it says, for number 2, it says state the domain of f of x in interval notation. All right? Well, if we want to state the domain, we have to go on the inside of the radical, the argument. That's what gives us our domain, right? So what you're looking at for f of x, if we have f of x equaling negative square root of 3 minus x, negative 3 minus x, pardon me, I forgot the negative. Negative 3 minus x. Then what we have to focus in on is the argument here. This part right here. The argument in the radical. Because in order for us to have a domain, that portion right there has to be greater than or equal to 0. Because you can't find the square root of any negative number. It'd be imaginary. It's not a real solution. Right? And so we're only dealing with real numbers here. So you must take what I have circled here in blue. You must isolate it, pull it out. Take that out of the radical. So look at negative 3 minus x. Pull it out, right? And you have to set it greater than or equal to 0, because it must be positive or 0. It must be a 0 or a positive number. Here's the word. Solve that. Solve it. Give me the interval. So in doing that, I have to subtract add 3 to both sides. Add 3. And 3's cancel out here. They go to 1 or 0. So I'm going to have a negative x greater than or equal to. And then I have 0 plus 3, which is 3. Then you must divide both sides by negative 1. If you're not careful, what you're going to forget is this. Whenever you have an inequality symbol, it doesn't matter which way it's going. If it's going this way, or if it's going that way, it doesn't matter. If you multiply or divide by a negative, you have to change the directions of the symbol. I divided both sides by negative 1. So we must change the direction of the symbol, and it's going to go this way. It goes from being greater than or equal to being less than, to becoming less than or equal to. Why? Because we divided by a negative. Like we said many weeks ago, that whenever something negative happens in your life, things change. So when you multiply by a negative or divide by a negative, and if the problem is an inequality, you have to change the direction of the sign. That's important. So my direction of the sign is changed. A negative divided by a negative is a positive. And 3 divided by negative 1 is negative 3. And there you go. And this is the algebraic representation. That is not interval notation. We need interval notation. Okay? So then what you are to do is to rewrite this in interval notation. All right? And so the interval notation is going to be, well, this is going to go to the left because the arrow here is pointing to the left. Make an arrow out of it. It's going left, right? So we're going to go all the way to negative infinity, but we're starting at -3, and it's a bracket because it's less than or equal to. So it's a bracket. So that's interval notation right there. From -3 all the way to negative infinity, including -3. All right. And so that's going to do it for lesson 8.1. And that's all there is to it, to the algebra of functions, adding, subtracting, multiplying, dividing. And so now what I'm going to do, I'm not going to stop. I'm going to keep on going. I'm going to go into lesson 8.2 right now. So if you have any questions about lesson 8.1, you can stop the video, rewind it, and go over it again. Or you can reach out to me, you can text me, or you can email me, and I'll be sure to help you. All right? Okay, so let's jump right into 8.2. So first, all of this got to go. So, let me get rid of all of this. All of this has to go. Okay, and just like that, it's gone. All right, 8.2. Okay, oh, well, it's not all gone. Erase this. Now we're looking pretty good. All right, 8.2. The composition of functions. And inverse functions. The composition of functions and inverse functions. The composition of functions and inverse functions. Here we go. All right, so first point. Let's say we have f of x and it equals 3x squared plus 3. And then let's say we have, all right, come on purple, g of x which is 3x plus 2. All right. So we have g of x, and you know what? Let's make these lowercase, not capitals. Let's make them lowercase. There we go. G of x, and let's make this f of x, lowercase. All right. So here we go. 1. Let's find f of g of x, which is the fog and then 2, we want to find g of f of x, which is the golf, and then number 3, we want to find f of g of -2. All right. So now how do you express all of this? What does this mean? Okay, so the word for the first one, this is f of g of x. That's how you say it. F of g of x. F of g of x. That's the first one. The second one here is g of f of x. G of f of x. Alright? And this is f of g of -2. Alright, so you got to put of in between each variable. F of g of x. Okay? So it's one function composed of another function. Basically, you're taking, you have one polynomial and you're going to insert the other polynomial into the one. Right? It's like me having my left hand here, and I'm taking my whole right hand, putting it in my left hand, and I want to evaluate it inside of the left hand. Right? Yeah, that's what's going on right here. Alright? So, here we go. Maybe if I write it out, I can show you. Let's do number one. Let's do the first one. Let's find f of g of x. Alright? So, number one, from right here. Alright, so we have f. Now notice f is in black. So here's f. Here's f. And what I want to put inside of f is g. G of x goes inside of f. So I want to write g of x right here. G of x. You see that? That's the point. This is the idea right here. You put g inside of f, right? So that's going to equal, all right, watch this. This whole function g, which is 3x plus 2. You see that? That whole thing must go inside of f right here where the x is. I'm going to dump this whole thing, 3x plus 2, right there where x is. So that's going to give me the following. That's going to give me this 3, parenthesis, 3x plus 2 squared plus 3. There we go. There we go. That's important. That's critical. You see this 3? Well, here it is right here. You see this x? This x is going on vacation. I've taken out the x and I put all of this, 3x plus 2, in its place. The square sign, there it is. The plus sign, there it is. The 3, there it is. That's how you do composition of functions, folks. I put all of g inside of f, and it looks like that now. So this x that was in f on vacation, and the substitute teacher now is 3x plus 2. Alright. And I guess the most important thing here, once you do your substitution, is to do the actual arithmetic. Let's do the work now. Alright, so here we go. So now this is going to equal 3 times 9x squared plus, alright, because we have to FOIL this out. In fact, let me just write it out for you. I don't want to hurry through it. Let me write it out for you so you can see it. So it's going to be 3 times, well look, that's 3x plus 2. How many times? Twice. So it's going to be 3 times, here we go, 3x plus 2 once, 3x plus 2 twice, plus 3. So it's 3x plus 2 2 times. So write it twice, 1, 2. Alright, so this is going to equal 3 times, and at this stage you got to FOIL. You got to FOIL it. So you got to go 3x times 3x, and that's 9x squared. And then 3x times 2, and that's plus 6x. And then this 2 times 3x, that's plus another 6x. And then this 2 times 2, which is plus 4. And then go back and grab plus 3. That's the whole folding technique. Alright, and this is going to give me 3 times 9x squared. Combine these two terms in the middle because they're like terms. 6x plus 6x is 12x plus 4 plus 3. And now take this 3 and multiply it. 3 times 9. That's going to equal 27x squared. Okay. And then go 3 times 12. Alright. Plus 36x. And then go 3 times 4. Plus 12. And then plus 3. Last step equals 27x squared plus 36x. And 3 plus 12 is 15. There you go. And this is what f of g of x equals. So f of g of x equals that. And there is our answer. That's going to get it. That is our f of g of x. It equals 27x squared plus 36x plus 15. All right, that's part 1. Part 2. Now let's go the other way. Let's find g of f of x. So this time g is on the outside. All right, so number 2, I want to find g, right, of f of x. So now g is on the outside and f's in the inside, right? Here's what it means. Watch this. We know that f of x is 3x squared plus 3. We know that g of x is 3x plus 2. All right, so we want to take f and put f on the inside. Where's f? Oh, f is right here. So now take all of this. See that? Take all of that, 3x squared plus 3, and dump it in to x right here. That's how you do it. That's how you put f inside of g. Take this 3x squared plus 3 and put it right there for this x. This x right here is going on vacation. Bring the substitute teacher in. All right? So here we go. We're going to have g. G is going to be 3. 3 times what? Bring in f now. 3x squared plus 3 plus 2. All right, let's go to work on it. There we go. Let's go to work. What is this going to equal? Well, this one's not as bad as the first one, because all we do now is just distribute. There's no FOILing here. It's not squared. So take your 3 and just multiply it right there. That's going to give me 9x squared, and then take 3 and multiply it right here. Plus 9 plus 2, which equals 9x squared plus 11, and we're done. That is what g of f of x equals. And that's a wrap on that. That one wasn't too bad. All right. And number 3. Okay, let me see what's, oh, now you want f of g of negative 2. All right. So I want, let me see, f of g of negative 2. Tell you what you do in this case. Start with the inside. Okay? Let's do, give me this first. Let's do that first. What is g of negative 2? In other words, put negative 2 inside of g, and let's see what we get. G is the purple. Let me do that first. So what is g of negative 2? That's going to be 3 times negative 2 plus 2, which equals negative 6 plus 2, which is negative 4. Okay, so g of negative 2 is negative 4. You got it? So this, g of negative 2, is the same as negative 4. So now I can rewrite this. So now this is going to equal, I'm going to keep the f. F of, I'm not going to write g of negative 2 no more, because I know what g of negative 2 is. G of negative 2 is negative 4. So I'm going to put a negative 4 right here. And so now, go ahead and do this one. So now put negative 4 inside of what? F. Put negative 4 inside of F. So what is that going to give me? So what is F of negative 4? Well, let's see. That's going to be 3 times negative 4 squared plus 3, which equals, do not multiply 3 times negative 4 first. That is not proper. That is not the order of operations. Square negative 4 first. That's going to be 3 times 16 plus 3, which equals 48, plus 3, which equals 51. And that, ladies and gentlemen, is the answer to the whole problem. Our answer is 51. Therefore, 3 dots, triangle, therefore, f of g of negative 2 equals 51. There's your answer. Found g of negative 2 first, got negative 4. Take this answer and plug it in as our domain of f. F of negative 4 is 51, and that's it. Alright? So that's the whole operation and ideology behind composite functions. How you use composite functions, okay? Alright. So now let's look at something different. Before we get into our inverse functions. I want to explain something called a one-to-one. And that's part 2 here. Okay, here we go. Number 2. Let's look at something called one-to-one functions. One-to-one functions. What makes a function one-to-one and unto? One-to-one functions. All right. Let's draw some coordinate planes. X, Y. Number 2. Y. Number 3. X, Y. And number 4. X, Y. Alright, we're taking a graphical approach now. Let's draw some graphs here. Alright, graph 1. Let's do a hyperbola. Graph 2. Let's do a cubic. Graph 3. Let's do a inverted absolute value. And graph number 4. Let's do a circle. All right. So now let's see. Now let's take a look and see if these graphs pass what we call the horizontal line test. The horizontal line test. Let's see what happens with these graphs. Let's see if they're one-to-one, okay? So to be one-to-one implies that for every horizontal line that you draw in each graph, for every horizontal line, you should only intersect the graph in one location. You can't intersect the graph in 2 locations, okay? All right, so for every one y value, there's one x value, okay? It can't be, 1 to 2. It can't be for every one y value, there are 2 x values. No, it must be for every one y value, there's only one x value. That's what makes it one-to-one. It can't be for every one y value, there are 2 x values. Then that would not be considered one-to-one. Okay? So let's see for every horizontal line that we draw, because the horizontals give us y values. Let's see for every horizontal line that we draw that we only correspond to one distinct x value. Let's see if that's true for our graphs. Come on, let's go. So if I draw a horizontal line, what color do I want to use? Blue. If I draw a horizontal line, okay, here we go. How many times did I touch the graph? Once. That's okay. That's one-to-one. One line, one touch. How about here? How many times do I touch? Once. One line, one touch. So far, so good. Do it again. One line, one touch. So far, so good. For every graph that I draw, it's going to be one horizontal line, one touch, which means that this graph right here, this is 1, 2, 1. This is a one-to-one function. That is a one-to-one function. Or, don't even say function, just say graph. That's a one-to-one graph or a one-to-one relation, because it's not always going to be a function. You say graph. It's one-to-one. All right, how about example number 2? Is it one-to-one? Is it for every horizontal line, one touch? Let's see. One touch. So far, so good. 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 Yep. This is one-to-one too. This is a one-to-one graph. All right, how about this one? Well, if I draw a line right here on the x-axis, you'll say, yep, one touch. But draw another line. Let's see if that one line only touches one time. If I draw a line anywhere else, like let's say here, uh-oh, we have a problem. Because I touched it once right here, and I touched it again right there. So this one is not 1, 2, 1. It is not one-to-one. Nope. It is not one-to-one. Because the one y value has 2 different x values. This is a 1 to 2. Here's what I mean when I say it's a 1 to 2. And it's not 1 to 1. This is 1 to 2. Watch this. Let's say this y value right here on the y-axis, let's say it's -3. And let's say this x value right here, that x value is 2. And let's say this x value right here is -2. So then this point right here is going to be -2, -3. And then this right here is going to be +2, -3. You see this one y value, -3, it has two different x values, -2 and 2. So it's 1 to 2, right? It's like this. This is x, and this is y, and this is -3, and this is -2, and this is 2. -3 maps here and there. It's 1 mapping to two different x values. So this is 1 to 2. It is not 1 to 1. Does that make sense? And in our last case, same thing. This is not 1 to 1. Same y value, but two different x values. So this is not 1 to 1. Okay? So, when we draw these lines, notice these are all horizontal lines. So we have something called the horizontal line test. The horizontal line test. And this horizontal line test is, used to indicate whether the relation is 1 to 1 and whether or not it is invertible. Okay? So it's used to tell us to determine if 1 to 1. This is another way of writing 1 to 1. 1-1. That means what? That means 1 to 1. Or it also can determine if relation is invertible. Does it has an inverse? Okay? So since this graph is 1 to 1, then yes, it has an inverse. This is invertible. In other words, it has an inverse because it's 1 to 1. This graph has an inverse because it's 1 to 1. So it does have an inverse because it's 1 to 1. This graph right here, not invertible. It's not invertible. No inverse from -infinity to infinity. You have to restrict the domain. There is no inverse here, and likewise, there's no inverse here. No inverse. Why is there no inverse? Why is it not invertible? Because it is not 1 to 1. No inverse because it is not 1 to 1. Okay? So the most important thing with the horizontal line test in determining whether a function is 1 to 1 is by drawing a horizontal line, right? Anywhere along the graph. If you intersect it only at one location for each horizontal line that you draw, it's 1 to 1. If you intersect it more than once, then it's not 1 to 1. It could be 1 to 2, 1 to 3, 1 to 4, so on and so forth. Okay? Alright. That's it for that. Okay. Now let's look at some inverses. Inverse functions. Alright, there's a process to find inverse functions. Alright, let me get the process. Process. The first thing you have to do, 1. Right? write f of x as y. 2. Interchange x and y. 3. Here's the work step. Solve for y. 4. After you solve for y, substitute inverse notation, which is f inverse of x for y. All right, so rewrite f of x as y, interchange x and y, solve it for y, and then substitute inverse notation for y. By the way, this is inverse notation. How do you read this? This reads f inverse of x. That's how it's read, f inverse of x. Do those steps and you should be okay. Let's take a look at it. Example 1. All right, example 1. All right. Example 1, what do we have here? Let me see, f of x equals 4x plus 1. Find f inverse of x. Okay, step 1, rewrite f of x as y. So when there's f of x, take it out and put y there. So y equals 4x plus 1. That's step 1. See? Write f of x as y. We did that. Step 2, interchange. Another word for interchange is switch. Switch the x and y. So where x is, make it y. Where y is, make it x. All right? If I switch x and y, I'm going to have now x equal 4y plus 1. All right? Step 2 is done. Step 3, asterisk is where the work happens. Solve it now for y. What do you mean solve it for y? This means I want to know what does y equal. That's what it means to solve for y. Y equals what? I don't have that here. I have an x equals. I don't have y equal. Let's solve it for y. Step 1, subtract 1 from both sides. Here I'm going to have x minus 1 equals 4y. All right? Take this situation right here and just turn it around. All right? So take this and turn it around. And now I want to write it as 4y equal x minus 1. That's better. Turn it around. And now divide both sides by 4. 4's cancel out. I have y equal x minus 1 over 4. Y equal. That's it. I have solved it for y. Y equal. And y equals x minus 1 divided by 4. Last step, substitute the inverse notation, which is this, for y. In other words, take out y and put the inverse notation. So then this means that take out the y and write it as f inverse of x equals x minus 1 over 4, and that's it. That's the inverse of that, is right here. That's all you're asked to do. Let's do another example. Example 2. All right, let me see here. What if we have 7? Let me see. G of x equals 7x cubed minus 1. Find G inverse of x. Same deal. Step 1, take out G of x, put in y. Y equals 7x cubed minus 1. Switch x and y. X equals 7y cubed minus 1. Solve it for y now. Okay? Subtract, add 1. Add 1. I get x plus 1 equals 7y cubed. All right. Take this fella right here. Turn it around. Okay. So 7y cubed equal x plus 1. And we turn it around because we want the dependent variable on the left and the independent variable on the right. Okay, whatever it is we're solving for, we want that left, because that variable is the one that depends on whatever is on the right. All right, so now let's solve that for y. So divide both sides by 7. And so y cubed equals x plus 1 over 7. Okay, so now the question becomes, you have y cubed. That's not what we want. It says here I want y, power 1. Y equals, not y cubed. So we have a cube here. How do you undo a cube? How do you break down a cube? It's just like if I were to ask you what breaks down or how do we undo addition, you say subtraction. And if I ask you how do we undo division, you say multiplication. So how do we undo something that's cubed? Well, to undo a cube, you have to cube root. You know, if it's cube, you want to undo it, cube root it. If it were cube rooted, if you want to undo it, cube it. So the cubing and the cube rooting, you know, they undo one another. It's just like a square root and a square will undo one another. So in this case, I have to cube root both sides. So I'm going to have y cubed, which equals x plus 1 over 7. And so I have to cube root the left side and cube root the right side. Got to cube root both sides. And if I do that, the cube root and the cube cancels out. And so y is the cube root of x plus 1 over 7. And then do step 4. Use the other notation. And so if I do that, what will we get? We're going to get that it's g. We get that g inverse of x equals the cube root of x plus 1 all over 7. And there's our inverse. All right. And there you have it. And there you have it. All right. Let's look at one more example. Okay. Example number 3. All right. Let's say we have p of x equals 5 over x plus 2. Same thing. rewrite it as y. 5 over x plus 2. Okay? How about we go ahead and let's switch the x and the y now. Switch it. Switch, interchange x and y. So x equals 5 over y plus 2. Alright. Now let's go ahead and subtract 2 from both sides. Minus 2, minus 2. And so now I have x minus 2, and that equals 5 over y. And then on this stage right here, let's take this and turn it around. Let's turn it around. Alright? That's going to be 5 over y, pardon me. 5 over y equals x minus 2. 5 over y equals x minus 2. Alright? And go back to what we taught you guys a while back, because there's something up here that you do not like. I see what it is, you see what it is, everyone that's watching this video sees what it is. Most math students do not like fractions. I get it, I do. But we told you how to eliminate a fraction. You know, the easiest way to eliminate a fraction is you take, the portion of the fraction that's holding it up, the foundation, the root of it. You want to break something down? Well, destroy it or break it down at the foundation or at the root, then you'll get it for sure. And so the root or the foundation of our fraction is being upheld by the y. The y is what's holding the fraction up. So the way you break down or get rid of a fraction is by multiplying both sides by y. Let's do that. So multiply this side times y and this side times y. You see that? And so the y's cancel out here, so we got 5 equal y times x minus 2. Okay? You see that? And if we do that, we're almost there. Last step. Now divide, because we're still going after y equal. We want y equal. Divide both sides by x minus 2. X minus 2, because they cancel out. And there is your y equal. So we got y equals 5 over x minus 2. Congratulations. Multiply both sides by y. You get 5 equal y times x minus 2. Divide both sides by x minus 2. And there you have it. So rewrite it now using notation. So rewrite this as, here we go, P inverse of x equals 5 over x minus 2, and there is our answer. That's the inverse. And that's it. Now with these first two problems, there is a shorter way, shortcut. Let me show you this. There's a shortcut for this first way to find the inverse, right? See if I can put the shortcut in here for you. Let me show you the shortcut. A shorter way maybe. Let me see. F of x is 4x plus 1. We need to find f inverse of x, right? Here's what I suggest that you do. Look at x. So look at, I'm going to call it this. Original. And then the inverse. Right? The most important thing you have to do is you have to start with x. Okay? That's the key. I don't have a, this is important. This is really important. You need to write this. This is important. Let me see. The most important thing is start with X. Start with X. Start with X. X is the key. So in this case, here is our X. See that? Start with X. In fact, so at the bottom, before I do anything, I'm going to say F inverse of X equals, start with X. And please tell me everything that is happening to X as you see it right here. So in the original, X is being multiplied by 4. You see that? So the first thing that's happening to X is being multiplied by 4. And then the second thing that's happening to X, you are adding 1. And so the inverse is going to be the opposite of what's happening right here. It's just that when you write it on the inverse side, don't start at the top and go across. No. No. Start at the bottom and write that first. That's the key. So instead of add 1, the first thing I'm going to do is subtract 1. And then right here, go up, multiply 4, then I'm going to have to divide 4. And that's it. So if I have an X, why am I putting an X? Because you got to start with X. Put an X right there, and then subtract 1, and then divide by 4. And there's my answer right here. That's some good stuff. That's the way they teach it nowadays in in schools. This Common Core math and Common Core approach to inverses and yada yada yada. Well, there you go. All right, so that's a shortcut for this one right here. Write the problem, write the original, start with X, and boom. In fact, I'm going to do example 2 right here too. Alright, so let me see. For example 2, let me erase this out. Let me put g of x here. And g of x is 7x cubed minus 1. We want to find g inverse of x. Alright, I'm going to erase this. Erase this. Erase this. Erase that. Make this g. G inverse of x. And I'm going to put an x here somewhere. Just put x. So let's see what happens. Put x. Okay, but the green says start with x. Here's my x right here. Notice I did not circle the cube. I only circled x. It's about x. And so I'm going to list now everything that's happening to x, starting from inside out. What happened to x? Tell me. Here we go. The first thing that happened to x, number 1. The first thing that happened, x is what? Cubed. It's order of operations. It's not multiplied by 7 first. That's incorrect. It's cubed first. So first it is cubed. That's the first thing that happened to x. It's cubed. Tell me the second thing. Then it's multiplied by 7. What's the third thing? Then we subtract what? 1. Alright, very good. That's everything that happened to x right here. It's cubed, then it's multiplied by 7, then you subtract 1. Now give me the inverse operation. Give me the inverse operation here, even in the inverse order. Don't start top and go to the bottom. No, on this side, start from the bottom and go to the top over here. So if I start from the bottom, give me the inverse operation. Don't subtract 1, but do what now? Add 1. And then don't multiply 7, but do what? Divide 7. And then do not cube x, but the opposite of the inverse of cubed is what? Cube rooted. Let's do these 3 things to x. Alright? So to x we have to add 1. Then we have to divide by 7. Then we have to cube root it. And there you go. The exact same thing. Okay. That's going to do it for 8.2. So there you have it. All in one lesson. 8.1, 8.2. Hang in there, ladies and gentlemen. We only have 2 more lessons to go. 8.3, 8.4. And then we'll get ready for test 5 and get ready for the final exam. And that's going to do it. All right. Thanks for coming. Thanks for listening. If you have any questions, text me, email me, and I will get back to you. And like I always say, continue to keep your hands washed, social distance yourself, stay home as much as you possibly can, and take things one day at a time, and everything's going to be okay. But it's going to be okay if you just have the right frame of mind, keep your mind clear, stay focused, and whatever you do, continue to always stay positive. All right? Okay. Thanks for listening. Take care of yourself.